Okay, we're going to do a couple examples now where we have something going on in the horizontal direction besides just a shift. That's going to be a little more involved. So we have a square root function here. And so our original square root function, remember, is this type of shape. I always like to pick nice perfect squares for my x values so that I get nice points to work with. Okay, so let's talk about the x direction. If you watched the video on stretching and shrinking, when we did the stretching and shrinking in the horizontal direction, we saw that we needed to end up with the same y value when we were done with that horizontal change. Now I know here we do have a vertical change, but we'll get to that in a minute. Essentially, what we need is we need to have the same number under the square root as we did before. So for example, in the first point here, we had a 0 under the square root because we were plugging in 0 for x. In this function now, for that first point, we still want to have a 0 under the square root, but that means we can't plug in 0 for x anymore. If we plug in 0 for x, that doesn't give us square root of 0. So what we need to do is take the stuff that has replaced x, so all the stuff under the square root in this one, and we need to say, all right, now that this has replaced x, I need this to equal whatever my original x value was. And so then if we solve that equation, that will tell us what the x value needs to be on the new graph. So in this case, the first point should have an x value of 2. So this point that kind of starts the shape of the square root graph is going to be an x value of 2 now. All right, and then similarly, we had a 1 under the square root for the second point. We still want to have square root of 1. So that means now that 2x minus 4 has to come out to be 1. And so x needs to be 2.5 for that point. And then for the last point, we had square root of 4. And so now we still want to have square root of 4. So 2x minus 4 has to come out to be 4. And actually, that means the x value will be 4. So that's how you want to get the x values if you have multiple types of horizontal transformations. You could do this method for the shifting, like in the first couple here, we had just a shift. You could set x plus 1 in this one equal to each of the original x values, and that would work. So if you want to do it the same way all the time, you can do that. If you prefer to just visualize the shifting, that's fine too. But the stretching and shrinking, really, you have to do with a mathematical operation, so it's accurate. Okay, and then that's everything that's with x under the square root. Now if we look outside of the square root, we have a plus 1. So we're just going to add 1 to our y values, and that will shift the graph up 1 unit. So those will be our y values. Okay, so I'm going to give myself some space to graph this here. Okay, so 2, 1, 2.5, 2, and 4, 3. Now, by the way, you might be wondering what happened, because we see a minus 4 in the equation, but really you can see it only shifted to the right 2 units because this point was at the origin before. so it moved right 2 units and up 1. We also had a shrink horizontally, so it shrunk back toward the y-axis before it got shifted. But why did it only shift 2 units? So here's what's happening here. If you factor out the 2, if you factor out a 2, you have x minus 2. So you have the shrink by the factor of 2. So all the x values got cut in half initially, and then here's the shift to the right 2 units. Let's do one more example here. So similarly here, if we factor out a negative 1, that changes the sign of both terms, and I'm going to write them in the opposite order then. So here we have a reflection horizontally, and then a shift to the right 4 units. So that might not be obvious at the beginning when we look at it the way it was originally written. But you can still do the same method that we did before to get the correct coordinates for the points. So here's our original square root coordinates, and then we can take the stuff under the square root and set it equal to each of the original x values to figure out what the new one should be. So 4 minus x equals 0, 4 minus x equals 1, and 4 minus x equals 4. If we solve each of those, that will give us the correct x values. So the first one should be 4. That's from shifting to the right, and then 3, and this one will be 0. So notice how I'm matching them up. So the 0 and the 4, the 0 became a 4 because when we set it equal to 0, we got an x value of 4. When we set it equal to 1, we got 3, so that's why the second point has the 3. Now, there's nothing happening in the equation on the outside of the square root, right? Everything was inside the square root. So the y column is going to stay the same. We had no vertical change here, so those are just the same as they were before. So I'm going to need a new page to graph this here. Alright, so let's see, we had 4, 0. And then 3, 1, and 0, 2. So it helps to be able to identify the type of transformation you're expecting so you know how to draw the graph in. So sometimes students say, okay, I got my points. How do I draw in the graph? Well, we know it reflected. So our original square root graph, remember, looks like this. So it reflected over into quadrant 2 because it was a horizontal reflection, and then it shifted to the right 4 units. So that's why we end up with this for our graph.